Right, okay, we'll make a start here now, guys. So, as I say, we're moving on to fireplaces and chimneys. So, I presume everybody knows what a fireplace is and what a chimney is. Okay, first of all, the most important things are the function and design features. Okay, so the functions of a chimney and a fireplace is to provide the maximum amount of heat for the comfort of the occupants. Okay. So obviously these days it's cold, so you have a fireplace to help keep the house warmer. To provide adequate protection against the spread of fire. Okay, so obviously in the fireplace there's a big danger that something could catch fire, so it needs to be as fireproof as possible. Okay, in other words, if you do have an emergency, that between the chimney and the fireplace, that'll give you a chance to get out of the house. Okay. Number 3, to ensure that the products of combustion are safely removed. Okay, so that's a product of a fire. I'm sure you've all heard of it before, so we'll have a look at that as well. To prevent downdraft, so you don't want any drafts coming in around the chimney or anything from outside. And finally, to burn fuel efficiently and safely. Okay, so fuel can be, turf, coal, logs, etc. Alright, so that's the functions of a fireplace and a chimney. And moving on now to the design features. So we have 6 design features. So the fireplace proportions and design. So basically you don't want it to look, you want it to look pleasing on the eye. So the proportions and the design need to look good in terms of the room that the fireplace is in. So if you have a small room, you're not going to have a massive fireplace. Whereas if you have a very big sitting room, maybe for example, you might look at putting in a bigger fireplace with a big mantelpiece, etc. Okay, combustion and heating methods. Okay, so they need to be considered in the design feature. Adherence to fire safety regulations. Okay, so there's a lot of fire safety regulations that need to be considered. Stability of the chimney against wind. Okay, so obviously the chimney sticks up over the roof, so it needs to be built strong. To prevent backdraft. Okay, so it's similar to downdraft. It's just air, cold air coming from the outside in. And weatherproofing of the chimney, so you don't want any water to be leaking in around the chimney. Okay, just make sure there's nobody coming in there. Alright, so the parts of a fireplace, so this should be fairly straightforward. I presume everyone will know these, majority of them anyway. So you have the hearth. Okay, so the hearth is usually the base here of the fireplace. An old style fireplace that you get in an older house, okay, would have a massive hearth. Okay, but these are the more modern ones. So the hearth is basically the base. The fire surround is this part here. Sometimes it's made of marble. Okay, so that'll go around the actual fireplace itself, which will be in here. And the chimney gather is the area here where the smoke from whatever fuel you're burning will start to go up and draft up the chimney. And you need to see the way that it's designed here so that any wind cannot blow down. Okay, we'll be looking at that later. This is the flue. Okay, so it's basically just brown concrete pipes that are laid. They go the whole way up to the top of the chimney to let the smoke out. The mortar sloped to form the throat or the flanchin here. Okay, so again that's to do with wind getting in, etc. Okay, so mortar is just another word for cement. Okay, and again here we have cement, so there's lime, sand and packing, and the ratio is 1:1:12. Okay, and then we have the fire back here, just okay, of the actual fire part. Okay, so that's some of the key parts of the fireplace that we'll be looking at. Okay, so if you have your book, guys, you can fill this in as you go along. It'll save you doing it later. So if you have your book, here, I'll open it up. So it's going to be question 4 on chapter 11. So if you do have your book, that's going to be on page 91. Okay, so you're just filling in the missing words. Okay, so fireplace proportions and design. So due to the huge weight of a fireplace and chimney system, it must have its own foundation. Okay, so when you're laying the foundation for your house, that wherever your fireplace is going to be going, there will be a separate foundation laid in there. In other words, a bigger foundation, so that you can start to build your hearth, etc. on. Okay, because there's a massive amount of weight, dead weight, on a chimney or a fireplace because it's all made of concrete and cement and sometimes marble. Okay, so it's all heavy. The second point there, the projections of a standard foundation are maintained around the fireplace jambs. Okay, so again, it's the same thickness, so it's 350, etc. Okay, so the same proportions are used. Now you won't need to worry too much about a foundation because you won't be asked to draw a foundation in the working drawings. Okay, but you just need to know that a fireplace has its own foundation, and anywhere you see the W here is in line with standard foundation measurements, so 350 would be your measurements there. Okay, so from any wall it will come out 350 as per our normal foundations. Okay, and number 3 there, or C in your book, for structural integrity the jambs should be a minimum of 200 millimeters thick. Okay, so these are the jambs here, so basically either side of where the fireplace insert will go. Okay, it's just 2 thick block walls. Okay, they're not going to be very high, they're only going to be whatever height your actual fireplace part is. Okay, and they have to be at least 200 millimeters in thickness. So you can see there, that's the measurement in the wee drawing here. Okay, and if you have your book there as well, you're asked to fill in the missing measurements, which are obviously 200 for the thickness of the jambs. Okay, moving on to number 5 here. So basically here we're looking at what the function of a chimney is. Okay, and so the fireplace proportion and the design, and we're looking at the functions, etc. Okay, so again, this is number 5 in your book on page 92 if you have it. So to direct the smoke from the fire up to the chimney, a precast chimney gather can be used. Okay, so this blue part here is a prefabricated chimney gather. Okay, so you can get them, and obviously it's a lot easier than making one on site, and you fit them in. So basically it gathers the smoke from the fire and it'll direct it up towards the chimney. Okay, the position of the gather, so again that's the blue part, it's highlighted in blue. It's obviously made of concrete, the same as the walls and stuff, but we just highlighted in blue here for the purpose of the diagram. The position of the gather is vital in order to create the required draw for the fire. When we talk about the draw, that's to draw the smoke up the chimney. Okay, so there's a specific design that needs to be followed for that to happen. Otherwise the smoke will just stay down in the fire and it'll spread around your room. Okay, which will not be very comfortable. If the gather is too high, a strong enough draw will not be created and the smoke will leak into the room. So that's just what I'm after saying. So basically, if you don't have a proper draw that's properly designed, the smoke won't go up your chimney, it'll come into the room and you'll be breathing it in. Okay, obviously that wouldn't be very good for your health. Number 4 here, an alternative to this gather is to use a special chimney lintel with a sloped face and to direct the smoke. Okay, it's basically a similar design feature, but it will be made on site using lintels. So remember, we put lintels over our window details as well. Okay, and they've got a layer of steel in between them to make them stronger. Okay, so they would just use that to build it up. Okay, but obviously the prefabricated one is a lot quicker, a lot easier, and ultimately it's a lot safer. Okay, so this is what they look like. So that's the precast chimney gather. As I say, it's just made of concrete. Okay, in the previous diagrams there we just had it highlighted in blue so you could see which one it is. And you can see here around the top, this is where the smoke will go up the chimney. There's kind of a design feature so that the chimney flue can actually sit on top of it. Okay, and the chimney flues, you'll build them up on top of each other similar to blocks. Okay, you'll put a bit of mortar in between each one. You'll build them up until it reaches the height of whatever height your chimney is going to be basically. Now the chimney will usually have to reach a higher point than the ridge of your roof. Remember, the ridge of the roof is the highest point of your roof, usually in the centre. So the chimney has to at least reach a higher point than that so the smoke gets away from your house and doesn't blow over the roof. Okay, or blow onto the roof. Okay, so these are just laid on top, so we'll have a look at them later on. Okay, so there's just a couple of them. Okay, so again, they're just built up and there's mortar put in between them. So this is what the early stages of a fireplace would look like. Okay, You can see here you have the fireplace jambs. Okay, so I don't know if you have this type of a fireplace at home and you look at it. Okay, you'll see that it's built out and there'll be jambs on either side, and then you have the precast chimney gather here, and then your mantelpiece would be on top of this part here, so it would. Okay, you can see all the fireplaces will come out this distance because the jambs have to be 200 millimeters thick at least. It can be a lot bigger, as I say, that'll usually depend on how big your sitting room is. Okay, so that is what that's what it looks like in real life whenever it's been built. So you have your two jambs either side, and you have your precast chimney gather here. Okay, and out the back there you can see that the precast chimney gather goes out a bit. Alright, so some houses, if you look outside the area where outside your house where the chimney is, you'll see that there might be an extra bit kind of boxed off because the chimney needs a kind of bigger thickness. Okay, so that's what your fireplace looks like. So moving on then, it's just another view of the same thing. You can see here there's a black layer of plastic, so that's our DPC. Now it's a little bit dirty here obviously because it was on site, but it's the black plastic, so that's laid from the foundation, between the foundation and where our building work for the jambs are done. Okay, and again this is to stop any moisture travelling up through the walls. Okay, so it's the same concept that we use it for, we looked at the start of the year for building our walls. Okay, so the DPC, damp proof course, stops any moisture travelling up through the walls. Okay, so this is just a sketch of the fireplace design, just to kind of give you an idea of what the detail is going to look like. So this is coming up from the foundation. You can see we have our DPC in here. We always highlight it in blue just because it stops moisture coming up through the walls. Here's the hearth, this grey area, and the superimposed hearth is basically whatever material you've chosen to make your fireplace out of. So it might be marble, for example, maybe it's timber. Okay, so whatever it is, usually you'll choose whatever material you want here. Okay, it'll be for the aesthetics and for the looks. Okay, and again the constructional hearth not less than 125 millimeters thick. So they're just talking about the thickness of this concrete hearth layer. It has to be at least 125 mil thick. Okay, if not thicker. Alright, so this is the one that has the lintel on it. So you can see the lintel has got its steel running through it to help strengthen it. Okay, more often than not now a prefabricated chimney gather is used. Okay, and these are the chimney liner flues. Okay, so they're always made out of kind of brown concrete material. Okay, again that is fire resistant. Okay, the brown concrete material is fire resistant. We'll be looking at that later. So this is just to show the kind of proportions or the minimum kind of measurements that have to be used for your fireplace. So if you have a fireplace that gets at home, you take out a measuring tape, you can actually measure it to make sure that, and you should find that it is at least these measurements if not bigger, but it should not be less. Okay, so this is number 6 again guys if you're on your book there. A fire hearth contains an open flame, so obviously there's an open flame in your fireplace because it's burning the whatever material you put into it, and it's vital that no combustible material comes into contact with the flames, so anything that can catch fire basically. The fire hearth must project 500 millimeters out from the fire and 150 to either side. Okay, so basically wherever your fire hearth, so wherever these two walls that we built out here, okay, wherever they kind of stop coming out, so the jambs, whatever distance they come out, so say they're out here a distance of 300, then you need to have another distance of 500 at least to the end of your hearth. Okay, the idea for the hearth to be at least 500 millimeters out is that there's less chance of something in your room catching fire. Okay, because it should be a safe distance away. Sometimes if you have an open fire and you're burning timber, sparks can kind of fly out sometimes of your fire, could land on something that could actually just catch fire. Okay, so that's why there should be nothing near your fire, at least within an open fire anyway, within 500 millimeters. Okay, non-combustible insulation is used behind a fireplace, and that's a minimum distance of 300 millimeters from the fire. Okay, so it's just a rigid insulation on the back. You can see here they've highlighted in yellow a thicker layer of insulation. Basically it's fireproof. Okay, so it won't burn. At least it won't burn for the first maybe hour if something happens. Okay, so that's just a special insulation so it doesn't catch fire. Alright, the fireplace detail, again we're going to do that when we get into school, but just to give you an idea of what it looks like. Look guys, we just have a typical foundation. Okay, so everybody should be able to draw this much, fairly straightforward. One of the very first drawing we done actually. The only difference then is we start to draw our fireplace and our hearth. Okay, so you can see that's the hearth, again 500mm, so you can see the jambs are going to be drawn up here now. That's the prefabricated flue lintel. Alright, and out here there's just two drawings done here, but they are just highlighting these here parts here. Okay, that's just to show you the measurements for the kind of prefabricated lintel area. So that's this one here is there, and this here is just the back of the fireplace, so you can see the design of it so that it directs the smoke up the chimney, and that's the measurements for it there. Okay, so this part here is the only thing you need to draw for a fireplace detail that is different to what we've done so far. Okay, you put in all the render, and that is what your final working drawing will look like. Okay, so that'll be a fairly straightforward one for us. Okay, it'll be a lot easier. All the roofing ones are going to be completely new. Okay, but again, as you can see, this one here is going to be different. Okay, just around here, around the fireplace. Okay, moving on. So we'll go, what time is it? So yeah, we've another we'll go another 10 minutes. So the wood pellet burners, I don't know if anybody has a wood pellet burner in their house or not, okay, but they're becoming more popular, and they're starting to appear on the exams when they talk about chimneys and fireplaces, basically because they're a renewable energy source, okay, and they're a more modern kind of a construction use. Okay, now this is on page 93 in your book. Okay, basically a wood pellet stove burns wood pellets. Okay, wood pellets are taken from a woody plant, okay, also known as an elephant grass. Okay, so it's just basically timber plants that grow really quick, so they cut them down, turn them into wood pellets, and they can replant them. Okay, so it's very renewable. Alright, so they're carbon neutral as well. Okay, so it's the carbon neutral, as the carbon created when burning the pellets was reabsorbed during the growing stage. Okay, so they're good for the environment as well. Okay, now these pellets can be quite expensive though. Okay, the pellets are automatically fed into the burner by an auger feeder. Okay, so obviously you can get one where you just put them in yourself, or you can get one that has a store out the back of it and it automatically feeds the fire as it needs the pellets. Okay, that's a kind of modern advancement. The pellets must be kept dry at all times and stored in a waterproof storage area. Okay, so like timber, if they get wet, they'll not burn very well. Okay, so you can see you have your fire there. There's an auger here that lets the wood pellets in. Okay, and it just works then as a normal fireplace. Okay, that's what they look like. So they look like a stove. Okay, so we're moving on to stoves next. They're designed like stoves, but they've got an extra power at the back, and you need an area that'll feed the wood pellets into the back. As I say, you can put them in yourself, okay, but they can burn very quickly, so it means you need to be filling the fireplace every half an hour. Okay, as I say, this is a kind of new approach, an environmentally approach that they're starting to push. Okay, so it has come up in the exams in the last couple of years. Okay, so number 9 there, or number 10, we're looking at the wood burning stove. So these are probably one of the most popular types of fireplaces in Ireland at the minute. Okay, wood burning stoves have gained popularity in recent years, so you might have something like this at home, a stove. They're generally considered to be more energy efficient than an open hearth. Okay, so if you have an open fireplace, you can imagine a lot of heat can escape, whereas if you have a stove, all the heat kind of stays in and can be used. A lot of wood burning stoves, or stoves in general, can be used to heat water. Okay, so they can heat the water in your house because they can have a back boiler built into them. So this is because they're controlled, so you can control the amount of air intake. So there's adjustable kind of hand wheels that you can turn to let more or less air in, depending on how much you need for your fireplace on any given day. So it makes the fire burn hotter with less smoke and fuel. Fire bricks in the stove store heat for longer. Okay, so you can actually buy fire bricks that are supposed to burn for longer. Baffles hold the exhaust fumes for longer so that the heat does not escape up the chimney. Okay, so there's a design inside it that stops the heat going straight up the chimney. Okay, so it keeps the heat in the room for longer. Where if you have an open fire, the smoke and the heat go straight up straight away. Okay, heat rises. Okay, so the stoves have a kind of built-in thing that doesn't let all the heat escape up the chimney straight away. Okay, so generally a stove will be a lot warmer than an open fire. Wood burning stoves are more environmentally friendly than oil and gas fires due to CO2 being absorbed during the growing stage of the timber fuel. Okay, now you may have a stove at home that can burn turf, coal, etc. Okay, that would not be a wood burning stove, it would just be a general stove. Okay, but there's separate ones that are called wood burning stoves where you can only burn timber inside them. Okay, so that's kind of the two environmentally friendly options. Okay, so if you're building a house now, they would try and push you towards these two options. Retrofitted stove. So if you have a stove in the house, this is what the working drawing looks like. Okay, so I mean you can build a fireplace around it, etc., to make it look more like a fireplace, obviously. Or some people might just have the stove sitting on a little kind of hearth area. Okay, but most people will put a mantelpiece or some kind of a design around them. Okay, wood burning stoves can be added to existing fire hearths. Okay, so if you did have an open fire and you decided you wanted to put a hearth in it or a stove in it, okay, you could put a stove in it. You take the fireplace out, put the stove in, and then you just connect a pipe that would take the smoke up the chimney. Okay, a solid stove pipe directs the exhaust from the stove to the chimney, so you can see that going up through the chimney. It's a flexible kind of material. A flexible steel or aluminium linear is run inside the existing flue up the chimney, so you can see it there. And a metal surround can be added to seal off the original fire hearth. Okay, so you can put a metal surround in to help, see around here. Okay, so obviously the original fire would be a lot bigger than a stove. It just stops the cold draft coming down the chimney into the room. Okay, so again, this is on 12 and 13, guys, which is on page 94. So we're just going to go as far as 15. We're just going to finish the part on stoves, and then it'll take us down as far as fire safety, and we'll look at fire safety in the next class. Okay, so an alternative design for a stove is to link the stove flue pipe with the existing chimney flue pipe. Okay, so this is the existing chimney flue pipe, so some people will connect the two together. Now the only thing about this is, as you can see the pipe inside your house. So some people might have a stove in their house and there's a pipe coming up from the chimney, coming down from the chimney connecting to the stove. Okay, again, that is cast iron. Okay, so it's cast iron, it's obviously iron, and it's usually kind of a black colour. Okay, when connecting the stove to the flue pipe, it is recommended that a vertical rise of 600 millimeters should be allowed immediately above the appliance, so that's the stove, before any change in direction. Okay, so you can see here 600 millimeters at least, so that the smoke can start to rise up the chimney without any kind of disturbance. And then after 600 millimeters, you can have your turns. Okay, that directs it up through the chimney. A stainless steel liner should continue up the entire length of the clay flue pipe. Okay, so they put a liner, they basically have to fill in the whole chimney area. Okay, so that is the stoves. So again, there's going to be a detail for the stove. It's going to be very, very similar to the fireplace detail, only obviously there's going to be a stove in it. And the pipes. Okay, so they won't ask you to draw one where you've had an open fireplace and you've converted it into a stove. Okay, they won't ask you to do that because there'll be too much drawn in it. But if you did get a stove, or it would be a wood burning stove that would come up in the exams nowadays, this is the kind of a design you'd be asked to draw. Okay, so So obviously you have a massive thick wall behind the hearth because that will be fully closed off. Okay, that would actually have to be 500 millimeters thick at least. Okay, and you would have your fireproof insulation around the back. Okay, again we'll look at them details when we come back to school, but just so you have an idea of what they're going to look like. Okay, so 14 here, so we just have 2 more to do. So this is your stoves. So for a room sealed stove, ventilation is added through a pipe that draws air into the fire from outside the building. So you can see here there's a pipe coming from outside, this could be out in your garden, going in to the back of your stove. So that just allows air or ventilation in through the pipe. Okay, so that sometimes can help your fire, and you can obviously close and open that from inside, okay, to allow more or less air into your fire. This type of stove has the advantage of not creating a draft for cold air in the room. Okay, so you wouldn't have a draft. So if you have a chimney or fireplace at home that's maybe very drafty, especially in windy weather or cold weather like we have now, okay, this fireplace obviously reduces that because the air inlet is only coming in through the back wall straight into the back of the stove, and as long as around the pipe is sealed, there should be no draft in your house because it's going direct into the back of the stove. Okay, and also this type of stove is suitable for use in a house that uses a mechanical heat recovery system. Okay, so don't worry about that last point. We have to look at heat mechanical recovery systems, but that will be next year. Okay, so that's just the room sealed stoves. Okay, so they're fully sealed. Again, this is probably the least important slide we've looked at. Okay, not really going to come up in the exam. Okay, new stoves. So new stoves do not require an inbuilt fireplace or chimney. So if you decide you want to put a stove in your house somewhere where there was no chimney, you don't need to go and build a chimney. Okay, you can use single or double line stovepipes to transfer it up through your house. Okay, but it obviously means you have this pipe going the whole way up through your house. Now you can see here they've boxed it off with plasterboard in the second story. Okay, so that could be going up through maybe a bedroom or something, depends what location, where the location is in your house. Most people will box it off so that you can't see it. Okay, and that's it going through the attic, and then it comes up through the chimney. Okay, now it wouldn't be as nice or traditional looking as a standard chimney. Okay, a ceiling support box is fitted to the joist to ensure that the stovepipe is secure and that it is not in contact with any combustible material. So again, combustible material is something which could catch fire. Okay, so you can see the design here. Very unlikely this would ever come up in an exam, but it is kind of a new approach to building stoves. Okay, so although it hasn't come up before, it doesn't mean it won't come up this year or next year. Okay, so we have to cover all the new kind of design features that are coming in for houses in general, because they do creep up into the exam. Okay, a plaster slab surround can be built on upper leaves to hide the chimney pipe. Okay, so that's what I was talking about here, just a slab, so it's just plasterboard to box it off so that you can't see it basically. An insulation and radiation fire shield provides support and ensures that the pipe does not come into contact with any combustible materials. Okay, so again, just so nothing catches fire basically. A storm collar and chimney cap ensures that the system is watertight. Okay, so a chimney cap on the top, obviously there's a gap from where the collar comes up to and where the chimney cap is, so that the smoke can obviously come out. The idea of the chimney cap is to, if not stop, at least reduce the amount of moisture that would come down into your fire. Okay, and the other thing there is the storm collar, so it's just a thicker area so that it has more strength in stormy weather. Okay, so that is the fireplace. That's what we're going to look at today just. Okay, so again, that's just the fireplace detail put in. We'll be looking at it again. Okay, so that should be fairly straightforward. Now there is a little bit of detail to be learnt around here. There's a lot of angles and stuff. Okay, but that'll be okay. Fire safety we'll leave until our next class. It's gone 20 past 10 there now. So what I'm going to do is I'll just stop